Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. This short video is just an additional explanation for the written answer section problem number 3 in spring 2019 Exam LTAM. You can find that my solution of that problem at smarturl.it/ko-LTAM-exercise 35, and these additional explanations video will be posted at smarturl.it/ko-LTAM-exercise 35E, E standing for the explanation. I'm posting this because students have asked me, and also while the fact that we use in the solution follows from the discussion that is in there, it follows after you do a little bit of work. So I want to show you that work. This is the very end of the solution of that written answer problem, where we're calculating the value of the retiree healthcare benefits. And in my study manual, you have this information that if we assume that the annual rate of inflation for the healthcare premiums is 100 times J%, and that in any year the premiums increase exponentially with age in such a way that B of x plus 1 t over B of x t is C, so that B of x plus 1 t plus 1 over bxt is C times 1 plus j. So the rate of healthcare premium inflation refers to passage of time, and the factor C refers to the age of the person. Then in a situation like this, A double dot B XRT, which is the cost upon retirement of the annuity paid as these healthcare premiums are paid, following the same pattern of payment, starting at 1 and then following the same patterns of any increases. It can be actually calculated as A double dot XR, where XR stands for the retirement age. So don't be confused. It's not a product of some two numbers. It's just the retirement age. That's the notation in the study notes, and I'm following it. Calculated at the interest rate I star, where 1 plus I star is 1 plus I, where I is just the regular valuation rate that we're using, interest rate, divided by C times 1 plus J, where you see the meaning of C times 1 plus J just above. And in this case, in the problem that we have there, I is 5% and B of YT is the benefit. Is 2000 times 1.035 to the power y minus 60 times 1.03 to the power t. That's given. So that we can take a look at what the value, well, we can deduce what the values of C and J are and figure out how this annuity works. And specifically, C is B of x plus 1t over B of xt, so it's 2000 times 1.035 to the power x plus 1 minus 60 and multiplied by 1.03 to the t, while the bottom part is 2000 times 1.035 to the power x minus 60 times 1.03 to the power t, and therefore that's equal to 1.035. So that's how we establish what the value of C is, and C is that rate of, it's not really rate of increase, it's a factor of increase of health care premiums due to age, due to aging of the person. Also, C times 1 plus J, that's the second formula we had there, that's equal to B of x plus 1 times T plus 1 over B of xt. And then we just plug in what we are given, and you see that this ratio is equal to 1.035 times 1.03, so that we see that J is equal to 3% or 0.03. And therefore 1 plus I star is 1 plus I over C times 1 plus J, so it's 1.05 over 1.035 times 1.03. That's approximately 0.9849444. And then I star is approximately negative 1.50556%. Don't be confused by the fact that we get a negative interest rate. That's perfectly okay. That can happen. And then we know that A double dot B of xrt is A double dot xr calculated at the interest rate I star, which is negative 1.0556%, and hence A double dot xrt is the same as A double dot xr0. So the value of annuity is independent of time elapsed since the valuation rate, and therefore we have this situation that the annuity values used in the calculation of the cost of healthcare are the same as the one given in the problem. So A double dot B of 63.50 is given in the problem as 30.420, and we need for the calculation A double dot B of 63.5.5. Well, no problem, because we can use A double dot 63.50, which is again given as 30.420. And then A double dot B of 64.5 at 1.5 is A double dot 64.50. So that's 124 given in the problem. And A double dot B at 65.2, so 2 years in the future, but at when Diane, the person in the problem, becomes 65. But that's the same as A double dot B at 65.0, so whatever that annuity is for a person 65 right now, it's the same, and it's 28.487 given in the problem. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. You can find it at the original posting of the exercise. And the solution that I just gave you is mine. Good luck in your studies and good luck on the test.